So I'm going to show you how to use MATLAB as Simulink just in case you haven't really used that before. Okay, so you need, as I said before, you need to install the MATLAB on your computer. And then once you open the MATLAB, you will see the first thing you will notice, or you should notice, is this. This shows the default path or the folder for the MATLAB. Just, we not further complicate things. Now this default says C drive users, that's my username, documents, and MATLAB. Okay, so copy the three files, the HEV data, the HEV model, and HEV2 plot. Download those from the Blackboard and copy them onto that folder. Okay, so once you copy these files onto this folder, then you will see in the current folder you will see all files listed here. Okay, so the first thing you need to do is, once you've done that, okay, and then you double click on this. Now MATLAB sometimes, because MATLAB is a huge software, so sometimes there's a delay when you click on something. Okay, so just be patient. Even if after you run the simulate, you open this window there, and it can still take some time for the files to open. Okay, so double click on the file called data hev underscore data.m. Now in there, there's many parameters about what conditions we're going to run, what's the maximum values we set. Now if you're interested, have a look, okay, of all the details in there. But the essential values that you need to change are in the first, second, and third line here. Okay, so it's this one and that one. Okay, control strategy equal to 0. So let me just change that to 0. Control strategy equal to 0 means we are using thermostat control strategy for the engine. Control strategy equal to 1, that's when you want to select the maximum state of charge for the battery. Okay, and then the D cycle equals to 1 represent the city driving cycle. If you want to use highway driver cycle, change that to 2. And 3 is a step, just ignore that. Okay, 4 is a sine wave. Okay, there's another parameter that I forgot to mention. Well, I'll probably mention it anyway. So if you use city or highway conditions, you can use either set this to 50 or 100. Okay, it's probably for the benefit of running the simulation, just leave that as at 100. Okay, only change it to 200 when we want to use sine wave and 200 seconds per cycle. Okay, so for your tasks, only one of them you need to change that to 200. The rest will be 100. Oh, sorry. For 8 tasks, there are 2 that you should set to 200. It's on my slide. Okay, on my PowerPoint slide, you can actually use 50, 100, and 200. I think 50 was originally used for the city and the highway driving cycles. You can change that to 50, but it should be also fine with 100. Okay, but so for the sine wave, there are 2 values to use. One is 100, the other one is 200. Okay, the rest of it, just if you don't want to spend too much time, and you can actually ignore the rest of it, it's basically trying to set up all the tables and lookup tables, all the part of the model. Okay, so once you're happy, let's say I will start with sine wave. Okay, so because that's easier for me to explain. So let's say we are using sine wave. So I set this to 4. We're using control strategy 0, that's thermostat. We are using 100 seconds per cycle, per sine cycle. So once you're happy with all these settings, click on top of here, there's various buttons, okay? Click this run, okay? Now this run, what we'll do is actually execute this file under the main MATLAB window. Okay, once it's done, because a part of it, at the end of it, I set a command to bring up the second model as well, so we can actually run the second model. Okay, so click and run. There may be a delay, okay, until you see that return comes back. So just keep an eye on this button, okay. So if I click, now it goes to pulse. Now, once this simulating file pops up, because that's the last command to execute, and this goes back to run. Okay, that means this file already run, and we have all the data under MATLAB. Okay, so we have all the data here, and it's actually defined on this workspace model as well. Okay, and then I'm going to run again because I want to bring this up. So once I run this, I brought up the first file will bring up this main module model file. Okay, again there's a click on this run button. Now this is probably the most this file, it takes the most time to run, so there will be a delay, but you can actually watch the bottom bar here. Okay, let me just close that. You can watch the bottom bar here, and it actually shows the status of your of the running. Okay, so if I click on this, and then you watch the bottom part, and okay, it says compiling, and then it goes the time. You should hear a sound once it's done, and there's no update at the bottom. That means it's been run. Okay, you can actually go back to the MATLAB model, see it's been run here. And now you've run that. Now the model will have produced all the results, but you need to see these results. Now this is where the third final graphs comes in. So go to the main MATLAB, the first MATLAB window you opened, and double click on this. Okay, you come up. Okay, now come up there. This one you don't need to do any modifications at all. Just click again, run. Wait until all the graphs pops up. Now in total, there are 6 sets of results this file produces. They're actually on top of each other. So if you're just using a mouse to move it apart, you can see the 5th one, you can see the 1st one, the 4th one, this one, and that one, and this one as well. So we can just go through them one by one. Okay. Now, just before I forgot, if you want to copy and paste the file onto your report, just go to Edit. It takes a bit of time. Copy figure. So go down, copy figure, and then you can go to your Word document and paste it. Okay. Now, figure 1 tells you the velocity or the vehicle speed, and there are actually 2 curves there. Okay, and they compare the actual speed and the target speed. Target speed is the drive cycle. So this is what, because I'm using a sine wave, but I'm shifted it to all positive. So start from 0, it goes to 40 miles per hour, and then comes down for the sine wave and go back to 0, and then go up and down. It just repeats itself like that. Okay, and in 500 seconds, that repeated 5 times. So every time it takes 100 seconds to repeat one cycle. And the simulation is total run for 1500 seconds. So the first graph, of the first plot, there are 2 graphs. One is the speed, and compare the target and the actual. You can see the controller works quite well. The vehicle is actually following the speed pretty well. The second one shows the instantaneous miles per gallon, the petrol, the fuel consumption. Now you can see it actually starts from 0, because in this strategy we have, when the vehicle is started, we have some electrical power stored in the battery. So the first so from there to there, it relies on the battery power, but also because we are accelerating, decelerating as well. So that battery is charged during braking. So you have some initial energy there, and then during braking, it charges the battery as well. So that the kinetic energy or the mechanical energy of the vehicle during braking is actually fed back. So you can see the engine. Now you can actually tell some sort of the vehicle is only start to consume some miles, gallons petrol. Start from there. Okay, so that's the first graph. Where's my second graph? Second graph shows the torque to the wheels, that's the traction torque, and then force to the wheels, that's kind of sort of traction force. And the third graph on the second figure is for all the running resistance. So we actually assuming it's actually running on a flat surface, so there's no gradient effect, as you can see there. And this sine wave is pretty much shows the air drag. It's going up and down with the velocity or the speed. And then you have constant running resistance there. Okay, so that's figure 2. Let me just close that because I explained it already. So let's just go to figure 3. Figure 3 shows the battery status. The current goes out, and then there's a bit of time that it charges. Okay, see, this is charge, this is feeding into drive. That is positive. Positive it's actually charging it, and negative means it's actually discharged. So you can actually see it's actually going up and down until you get to the time when the engine is switched on. Then the battery is charged more often, because we are using the thermal control method. So therefore, the engine is not switched off until the battery voltage drops to battery state of charge drops below 60%. So this is state of charge. Initially, we have 75%. So it gets charged a little bit as from the braking effort, but over time the state of charge gradually goes down until you get to 60%. Then when the engine is switched on, then the battery starts to get charged again. Okay, now there will be times where the battery can't be charged at full rate because the engine needs to provide for the traction effort as well. The voltage across the battery goes down with the charge until you get to there. So the voltage change is relatively small. So at 75%, you get 176 watts, and when you get 60%, it's only dropped to 160, around 666. So it's not really that critical. The battery, the battery voltage is not really a good indication of the state of charge. Okay. Now, if you want to read the values out, you can actually move your mouse to there, click on there, and you get some. Oops. Let me just get rid of that. Never mind. It won't go. See, if you double click on there, you give you a value there. Okay, that's number 3. Where's number 4? Number 4 shows the motor speed. Okay. And so you have speed, motor, of course, it needs to drive the car, and then the motor torque and the motor power. It's pretty sinusoidal because that's what you needed to drive the vehicle. There's 5. 5 shows the generator speed. Now, before the engine is switched on, there's no speed at all. It's not charging. It doesn't produce. It doesn't take any torque. There's no power either. Only after the engine is switched on. That's in figure number 6. So you can see engine is kept at 0 and then go up after the state of charge dropped to 60%. It starts to go up. Okay, that's engine torque, engine power. So total of 6 sets of results for different parts of the powertrain. And you can copy and paste onto your graph. Now if I just go, this is the plot. If I just go back and run another one. Okay. If I change that to 200 cycles, so that will be a sinusoidal, but with lower frequency. I'm going to run that. And then it brings up, don't forget to click run for the second model as well. Otherwise you will get you won't get any values out of it. So wait until it sees compiling. It's running. Okay. Now it's ready to plot. So I'm going to close it, minimize that. I'm going to use the plot, and I'm going to use the plot run. Now, the thing I want to emphasize for this one is, let me just go back to the first one. Now you can see the change of the speed now takes 200 seconds to go through one cycle. So the frequency is lower. Now the consequence of lower frequency is that if I bring you the second graph, where's my... No, that's okay. Second graph, I don't need that. Oh, I need the battery one. Where's the... I'm going to close that. Oh, here we go. Now you can see here, the battery current discharges and charges back, and discharges and charges back, and charges a little bit. As you can see, the state of charge starts from 75, it goes down, and it recovers a little bit because the dynamic braking or the regenerative braking. And actually by the end of 1500 seconds, we are still above 60% for the state of charge. So in this mode, within 1500 seconds, the battery is enough, because now you are accelerating, decelerating slower at a slower pace. So it consumes less energy there for the second condition. And that will see, if you look at this generator speed, if you look at the figure there, generator, there's nothing there. If you look at the engine, there's nothing there. There's a speed, the torque, and the power. They're all 0 because the engine is not switched on. So let me just look at this engine. Where's my engine? Motor is fine. It's doing what it's supposed to do. It's driving. Now, engine is here. See, there's nothing on the engine because the engine is not switched on. But if I change that, if I change the condition to 1, I'm going to do a rush city drive. Okay, so I'm going to change the TC to 100, and let's see. It brings up this one. Now I can run it. Wait until it finishes, and then okay, minimize that. I'm going to bring up the plot. Okay, so run this. I want you to show you the speed profile first. You can see this one. I'm going to maximize this. Okay, now over here, because it's a city drive, so you can see the speed start from 0, goes up and slow down, go up, slow down. So there's a lot of changes. And now you can see some difference between the target speed, the required speed or demand speed, the actual speed. The speed actually the actual speed is actually next slightly behind. And you can see when the batteries start to be charged, it's about here. Okay. Before that, it's all been run on the battery power and braking as well. So let me just get rid of that. So let's have a look at the battery. So you can see negative battery car means it's taking energy out of the battery. Positive means you're under regenerative braking. So the braking power is actually fed back to charge the battery. So you can see the battery state of charge goes wobble a little bit, depending on how much you charge it, and then eventually it reaches the minimum 60%. And this is where the engine is switched on. So it's being switched back. And let's see, just see the engine, see if I look at that. That's a generator. You can see this is exactly when it starts to work. Okay, before that, there's nothing there. Engine switched on at this time. Okay, and let's just run one more. Maybe I'm gonna run something else. I'm gonna use strategy 1. That's the maximum. Try to keep the maximum state of charge. I'm going to run a sine wave. I'm going to use 100. Run. It brings up this one, and you can wait for this to finish, and then you click on this one. Start to run. Okay, there's a problem here. Let's just try a different one. I'm going to use 200. Now you stop that 500 second. So the message there is that, okay, now I have a fix for this, guys. So if you stop at 500, now if you go down, look at the T stop here. Change that to 500 because you stopped on this computer. On a different computer, it actually runs for 1500. Now this computer, I don't know why it doesn't run, because maybe something's wrong with it. So if I change this value, if it doesn't work, normally I would expect to have 1500 seconds for length. But if you stop running after a while, especially for the maximum state of charge case, it tends to it's more computational intense, and sometimes it creates problems. So try to reduce that time. That's the overall time it runs, okay? And you can adjust that time to as much as you, as long as you get some results. Okay, so 500. Now it's done. Okay, it's not pop up with some message. Now we can have a look. 500 is for city and a highway and or sine wave. They should be fine. We should have enough data to actually have a look. Let's have a look what we have here. So I'm going to run this. It's still running. And the figures coming out. Now, just look at what's the engine doing. See, the engine being go up and keep the maximum, go down, go up, go down, go up. So the engine being very busy. And also, the generator, of course, is driven by the engine, therefore it's going up and down as well. If I look at the motor speed, that is the speed we need to drive the vehicle. What is that? Talk to the wheel. Where's figure 1? Figure 1 is this one. Vehicle speed. That's a highway drive condition. Speed goes up and up, accelerates and keeps there, and it continues like that. Okay? But the engine there, you can see the fuel and efficiency, it goes up and down, depends how hard you're on the accelerator pedal as well. Okay? Highway, if I change it to 100, if I change it to 50, does it work? Let's see. I'm just experimenting with different settings and to see what we get there. That would work. Would that allow me to run a bit longer? No, it doesn't. Okay, so basically, for control strategy 1, the maximum state of charge, you will need to reduce the runtime, okay, to around 500. And normally I would want 1500, but the MATLAB doesn't seem to like it, so you will need to actually have that to run at a shorter time. But basically, this is what we have for your simulation. Okay, so again, just to summarize, 3 files, 1 to run, and to give data. Second one will be run the model to produce results. Third one will be producing the plots for you. If you want to copy and paste the file, just click on the figure and edit, copy figure, and then you can paste it. Okay, so that would be the end of my, let me just try to